Hi class, today we're going to be discussing solution concentrations and reactions. This is chapter 9.4. So when you're making punch, you can add, you have a pitcher of water and you can read the directions, but you don't have to follow them correctly if you don't want to. And you make punch based on taste pretty much. We can't do that in science. We need to have it as accurate and as specific as possible in order for us to carry out our reactions. So now we're going to be looking at solution concentrations. Now, this is a general formula here, and it is made up of a amount of solute, and the amount of solute can be in grams, milliliters, or moles. And the amount of solution can be grams, milliliters, or liters. And amount of solute over amount of solution makes up the concentration of a solution. So the first one we're going to look at is mass percent. Mass is M and M, or it could also be used by the term by mass. By mass means exactly what the M over M means. And mass is grams over grams. So the concentration by mass, there it is right there, of solute in mass of solution. So we have a mass percent, which is mass over solute, over mass of solution, and the solution is made up of the mass of solute, again, which is what is up here, plus the mass of solvent times 100. Now, if we use this as we set everything to a certain parameter, so 100 grams of solution, if we want a mass percent, and then we have a certain amount of grams. So this would be a general if we were given a word problem, but you might be given something specific indicating that you would need to use this. We'll cover that as we go on. But it's also a conversion factor. So if you have a mass percent here, if you need to jump to grams of solute over grams of solution, the bottom is always going to be grams of solution. And whatever's listed as the mass percent is the grams of solute, and I'll show you an example of that. So here we have 42 grams of water is added to 8 grams of potassium chloride. The mass percent concentration is 16%. So that's mass over mass. So here we need to determine which is the solute, which is the solvent, and then set them up so we can see how we got to 16%. So the solute is 8 grams. The solution is the solute plus the solvent, which makes 50 grams. So we set up 8 grams over 50, times that by 100, and our answer is 16%. So if we were given a problem with this, 16%, the first step you need to do is take it out of percentage. You do that by using this formula here. The 16% is now 16 grams over solute per 100 grams of solution. And I'll show you more examples of that. So what is the mass percent of sodium hydroxide in a solution prepared by dissolving 30 grams of sodium hydroxide in 120 grams of water? So what are we given? We're given our solute and our solvent. We know it's mass percent. And we have our formula, which is mass over solute in grams and mass over solution in grams times 100. So if we set this up, we plug in where it needs to go in the formula, times it by 100, it is 20% mass percent. So this is a 20% sodium hydroxide solution. Now this is an example here. If we're given a problem with 20%, what this means is that the 20 would go here in grams of solute over 100 grams of solution. So we are able to convert back and forth if you're given a percent, because percents are always out of 100. A solution is prepared by mixing 15 grams of sodium carbonate and 235 grams of water. Calculate the mass percent of the solution. So we're not going to really worry about what's been given to us. We're just going to solve it. So we have the solute and the solvent, and we know the formula we have to use. So let's plug it in. 15 grams of sodium carbonate, 250 grams of solution. But wait, this doesn't match that, and it shouldn't, because this 15 plus 235 makes up the 250 grams. If you use just this, you are omitting the 15, and it's going to be wrong. You have to use the solute on top, and you have to use it on the bottom if you're only given the solvent. We were given the solvent. We were not given the solution. So the terminology in word problems is very, you have to pay attention. You can't take for granted that just because you know how to solve a problem, that is the way the problem is asking for it to be solved. You might have to pay attention more to catch it before you make mistakes like that. So 15 plus 235, add together, this produces a 6% solution. Now we're going to look at volume over volume. The volume percent is the percent of solute liquid to volume. Let me just read this again. The percent volume of solute to volume of solution. So this is in mils over mils. So it's the same setup, but now we're just using different units. So volume of solute over volume of solution. And the bottom one, if we set it to 100 mils so we can use percents, is whatever the mils of solute are over 100 mils of solution. And the last one is mass over volume, and that's going to be M over V. So it's percent in grams of solute to volume of solution, which would be in mils in here. So you could see, so if we had to use a percentage, grams of solute over 100 mils of solution. So mass per volume is grams over volume of mils. So write 2 conversion factors for each solution. So this is exactly what I've been setting up for. You take this and put it into a conversion factor to start a problem. So if you're only given a percent, you need to get it out of percent into something else that you can use. So for the first one, 8.50% can be pulled out where 8.50 grams of sodium hydroxide over 100 grams of solution and vice versa. This gets confusing for people, but this is how we set it up for percent. It's always 100 grams of solution over whatever the solute is. And that's what this is, solute over solution. 8.5, change it to grams. Second one, 5.75%. This is volume, so we have 5.75 mils of ethanol over 100 mils of solution and flip it. Last one, 4.8 mass, 4.8%, but this is mass over volume. So if we pull that out, this has to be in grams, 4.8 grams over 100 mils of solution and flip them. Why are we doing this? Because this is how you get out of problems, word problems when you're stuck. You have to know how to convert from percent, and it's really not a big deal because everything is always 100. Molarity. So molarity is moles of solute over liter of solution. In chemistry, this is the most that you will use out of any other concentration unless you're working in a lab. We tend to use molarity all through chemistry. So if anybody's planning on going on, you will become best friends with molarity over everything else. Molarity is moles of solute over liters of solution. So if you're given a 1.0 molar, and it's a big M, of solution of sodium chloride, it's defined as 1.0 mole of sodium chloride over 1 liter of solution. Yes, the solution keeps the moles of, it's over 1 liter, so solution, moles, and solvent, solute. Here we go. Let me show this over here, but you don't really have to worry about this too much this way. We always just leave it as 1 liter. Here is, just omit what I said. I'm going to confuse myself and you. 1 mole. So let's say that this is 1 mole of sodium chloride in here. You've weighed this out. You know what equals the sodium chloride. 1 mole of sodium chloride equals to. You pour that in the volumetric flask, and then you add water until you get to the line of the volumetric flask for 1 liter. And that makes a 1.0 molar sodium chloride solution. If we were in lab, you would have done that. Okay, so this moved. I apologize here. Well, what is the molarity of 0.500 liter of sodium hydroxide solution if it contains 6 grams of sodium hydroxide? This is not a difficult problem. You just have to learn how to break it up. So it's giving you 6 grams of sodium hydroxide, but we know how to convert from grams to moles. That's not a big deal. And we're given the volume of the liter, 0.500 liter of sodium hydroxide. So we know that molarity is moles over liter. So we can very easily determine this problem. We need some conversion factors. So we have 1 mole of sodium hydroxide is equal to 40 grams of sodium hydroxide. We can place them into conversion factors here from the equality, and we need to get the moles. We already have the liter part. So 6 grams of sodium hydroxide, set it up. We determined that we calculated 0.150 moles of sodium hydroxide. So now we have the mole part of this problem. So we look at what moles are. Molarity is moles over solute over liter of solution. So we have our moles. We also have our solution. So we're going to plug these in, and it's going to be 0.150 mole over 0.500 liter of solution, and that gives us a 0.300 molar sodium hydroxide solution. What is the molarity of 0.225 liters of potassium nitrate solution containing 34.8 grams of potassium nitrate? So we're not going to worry about this. Let's just calculate the problem. So here, state the given and needed quantities. So we're given 34.8 grams of potassium nitrate No big deal. We know how to convert from grams to moles. And now we are also given our liters here, our volume. So 0.225 liters of potassium nitrate. So here we have our conversions. So we know that 1 mole of potassium nitrate is equal to 100.11 grams, and we can set that up. And now we're going to take the grams part, and we're going to determine what our moles are. So we have our moles as 0.344 moles potassium nitrate. So we have this part checked off, and we are given that part from the problem. So now it's just a matter of plugging that in, and it gives us 1.53 molar potassium nitrate solution. So here is our 0.344 mole that we calculated here, and we have our liters of solution. By the way, you can be given a problem like this, but the liters may be changed to milliliters, and you would have to convert it to liters in order to do the problem. Make it easier on yourself. Just convert it. Okay, so molarity as a conversion factor. So what if you're given the answer, but you need to work it out into maybe what the mass was that was needed to be weighed for this? You need to be able to pull it out, just like percent. So if you're given 3.5 molar HCl, this spread out, I apologize to that what this means is you have 3.5 moles of HCl per 1 liter of solution, and you can use that as conversion factors. So if you're given a molarity, know how to pull it out into conversion factors, because molarity is really used a lot. Okay, so here are some conversion factors from concentration. So this is kind of a summing up everything. So you're given mass by mass. So this tells you how to break it down and how to use it as a conversion factor. You're given volume by volume, and it breaks it down, what it means, and how to use it as a conversion factor. You were given mass by volume, what it means, and how to break it down. And also same for molarity, what it means and how to use it. This is something you will have to know. You will not be given this. How many grams of sodium hydroxide are needed to prepare 75 grams of 14% by mass of sodium hydroxide solution? This sounds very difficult. It really isn't. You guys have been doing a lot of stuff. If you're all the way up to chapter 9, you've been doing calculations. You just have to take the steps to break it down and use some of the knowledge that you already know. So let's see what we're given. We're given 75 grams of a 14% solution. We need grams of sodium hydroxide. We have a percent factor to use. So the first thing we're going to do is if you have to make like a stepping stones of how to get to the problem, you should. Yes, it may take you more time, but the better you understand things in the long run, the less mistakes you make. So we have grams of solution. We need a percent by mass, and then we need grams of solution, because that is what it's asking for, is grams of solution. Okay, so let's see the qualities and conversions. We have 14 grams of sodium hydroxide over 100 grams of solution. How did we get that? By changing the percent. 14 is the solute, so that's 14 grams of solute over 100 grams of solution. So this is asking for how many grams to make a solution of this amount with this concentration. So I'll go over it again. So now we set it up. We have 75 grams of solution, because that's what it's asking for, is a solution. This is the solute. And we've pulled out the 14% to make it a conversion factor. So solutions cancel out. We need 10.5 grams of sodium hydroxide. So how many grams of sodium hydroxide are needed to prepare 75 grams of a 14% solution? So what this is saying is that they want the concentration to be 14%, and they want this amount of that. So this is working backwards in a sense with given what here is and break everything down. But it's really not a complicated problem. You can see 75 grams. Know that that's what you need, because this is a solute. We want a solution. So 75 grams of solution. Use the conversion factor of the percent, and it gives you the problem, the answer. Not difficult. You just have to be comfortable with the terminology. How many grams of aluminum chloride are needed to prepare 125 mils of a 0.15 molar solution? So again, let's jump ahead, and this box moved as well. So what are we given? We are given 125 mils. I apologize to skip. Some of the stuff, I go through it, but I don't catch everything, and when I save it, I think it changes on some of the stuff, because I look at every page. So we are given 125 mils or 0.125 liters. I told you it's easier to get this out of mils and straight into liters, so that you can plug into the calculation. We need grams of aluminum chloride for the solution, and we're going to need the molar mass and the molarity. So here's what you want to call like maybe stepping stones. We are given liters of volume, so we're given liters of solution, and we're going to need a molarity in order to get to moles. So the volume here needs to cancel out with the volume of the moles, the molarity, the molarity formula. The liters here will cancel out with the liters here. That will produce moles, and then from there we can get the molar mass to grams of solute. So write the equalities out. So we have 0.15 moles of aluminum chloride equals 1 liter of solution. That's the mole. That's breaking this down here. That's what we have. Don't be afraid to use this. This comes in handy if you thoroughly understand how to pull out these conversion factors. And then we need grams because we're going to have moles, but we need to get to grams. So 1 mole of aluminum chloride equals 133.33 grams of aluminum chloride. And we are going to plug this all in. So we are given a solution. So how many grams of aluminum chloride are needed to prepare 125 mils of a certain concentration of solution? So we convert this part to liters. It makes it easier to work it here. So we start with our volume, change it to liters. Now we pull out the molarity and set it up as moles over liters of solution, and that will allow these to cancel out. Now you have moles, and moles, you already know how to do molar mass. This gives us 2.50 grams of aluminum chloride. So if you had to weigh this out, you would weigh out 2.50 grams of aluminum chloride and add it to 125 mils of solution of water, and that would produce this concentration of a solution. So chemical reactions and solutions. I'm showing you how to do this because now we're going to use it all together with balanced reactions, how to pull everything out of word problems. So when chemical reactions involve aqueous solutions, we use the balanced chemical equation, the molarity, and the volume. So if you're given something and it doesn't make sense, chances are they're expecting you to create the balanced equation so you can see the moles on it. Let me go through here. So zinc reacts with HCl to produce hydrogen gas, H2, and zinc chloride. How many liters of a 1.50 molar HCl solution completely reacts with 5.32 grams of zinc? Now, if you're thoroughly confused here, you have to look at the balanced equation. The balanced equation is going to get you what you need. Now, if you're given the word problem, but you're not given the balanced equation, then that means they're expecting you to balance their equation so you can see what steps need to be done. Let's break this down. First step, determine what you have. We have 5.32 grams of zinc, 1.550 molars of molar HCl solution. We need liters of HCl solution. We're going to connect with the mole to mole factor, and you will need the equation. So if you're ever missing something, it's probably the equation, and they're expecting you to pull it out and balance it. And you're given the reactants, so you should be able to produce what the products are. Okay, so write a plan. So we're going to start with the grams of zinc right here. Molar mass of zinc, because we don't really work in grams, we want the moles, and then we do a mole to mole factor by looking at the equation and the coefficients of it, and moles of HCl, molarity, and the volume. So let's take a look at all the qualities and conversion factors. We have 1 mole of zinc equals 65.41 grams, and we can set that up as a conversion factor. We have 1.50 moles of HCl equals 1 liter. That has to do with the molarity. We can pull that out and use that as a conversion factor. And then we have 1 mole of zinc equals 2 moles of HCl. Where did that come from? Well, that comes from the actual balanced equation. This is why you need the equations. Not everything is 1-to-1. And this means 1 mole of zinc for every 2 moles of HCl. And if you don't do that, your problems are going to be wrong. So we have a conversion factor of 1-to-2, and it's very important on this. Okay, so now we just set everything up. We have 5.32 grams of zinc. We use the molar mass of zinc. We use the ratio from the balanced equation of the zinc being, the zinc here of 1 mole of zinc is over 1 mole of zinc per 2 moles of HCl. And we ran out of room here, but now we use the molarity of HCl, and that gives us 0.108 liter of solution. So how many liters of a 1.50 molar HCl solution completely reacts with 5.32 grams of zinc? It is a 0.108 liter of solution. And here is a concept to give you a better idea of how to do this. If you start out with grams, it gives you the next step of what you need to do. And then which gas law for gases, but we're not really worried about that one right now. So if you have grams of A, you need molar mass of A, gets to moles of A, you need the mole to mole factor, which is the balanced equation, and then it'll give you on to whatever steps you need. And the same thing goes for solution.